When you have real-world data and you've got a scatter plot or some other given information or maybe a graph to look at, how do you write the equation for that? First of all, we need to determine if this is a sine or a cosine function. We've been told that, I will tell you that it is a sinusoidal function of some type. Now, some people think it's a sine function because it goes up and then it comes down. However, you need to think about the realism, the real-life application of this. This is showing a year's worth of temperatures. In January, the temperature's low. It goes up to high temperature in July and back down to low again in December. So if this were half of a sine cycle, would it make sense then for the temperature to go down like this, creating a wave that looks like, let me draw it in. Would this make sense to have temperatures down here so the following year the temperatures are down here instead of up here? No, that doesn't make any sense. What's going to happen is after 12 months, it's going to start over again. We're going to go back up and have another cycle of the same type of temperatures. So this has to be treated as a cosine graph. So we've got a cosine graph. Now notice that the cycle of our cosine graph appears to be upside down. So this is an upside down cosine graph. So we'll have to keep that in mind when we write our equation. Now the sinusoidal axis is the point that's halfway between the high point and the low point. If you look back at your data, you'll see that we have a high point here and a low point here. The high point here is the month number 7, and it's 75.4 degrees average temperature in July. This is month number 1, and it is 25.5. The sinusoidal axis is the halfway point of the y values, so I need to take these 2 points and average them to find the middle. So if we add up 75, I'll kind of go do this over to the side, 75.4 plus 25.5 and divide it by 2, we end up with 50.45, and that's our sinusoidal axis. The amplitude then, so I'll just kind of draw this in, 45, 50, so it's kind of about right here. The amplitude is just the distance then between the 50.45 and the 75.4. So we take 75.4 minus 50.45 and we get 24.95. Now the phase displacement, remember, is the x value of the starting point. A starting point for a cosine cycle can be either the high point or the low point. If it's the high point, then we have a right side up cycle, and so we would use a positive amplitude. If we start at a low point, it's an upside down cycle, so we have to use a negative amplitude. Either one is fine, you just have to make sure you write the correct equation. So I'm going to put 2 possible phase displacements. One of them would be x equals 1, that would be our low point, and the other one is x equals 7, and that would be a high point. And we'll write an equation for each one of those phase displacements. Now the period is how many units it takes before the graph starts to repeat itself. So we have 12 months here, and then it would start to repeat itself. And that makes sense because there's 12 months in a year, and then we cycle over again. So the period is actually 12. Don't make the mistake of thinking it is the last point minus the first point, 12 minus 11, because 12, it is not the next low point. The next low point would actually be down here at 13, then the next January. So if you go from January to January, it's going to be 12 months, not 11. That means b is 2 pi divided by 12, or pi over 6. So we're ready to write the equation now. So we can say y is equal to 50.45 plus 24.95 times the cosine of pi over 6 times x. Now I've got a positive amplitude here, so I'm going to use the x minus 7. If I wanted to use a negative amplitude, I could also write y equals 50.45 minus 24.95 cosine pi over 6 times x minus 1. So that would be the difference, is starting at a high point versus starting at a low point. Anytime you have a high point and a low point, you know you can find all of this information, because from the high point to the low point, from the low point to the high point, either one, tells you half of a cycle. So from 1 to 7 That's half of a cycle. And so I can always double that to find the period. Half cycle equals 6. Now, what do these numbers tell us? All of these numbers then are going to represent something in real life. Since this represents a real situation, what does the period represent? Well, the period represents 12 months or 1 year. So that is one complete cycle of temperature in a year. The sinusoidal axis, since it's the average of the high and low temperatures, we can think of that then as the average yearly temperature. So we have the average monthly temperature. This would be the average yearly temperature. The amplitude then, since it goes up and down from the sinusoidal axis, tells us how much temperatures vary from the average. Now, what would happen if we reflected the whole graph across the sinusoidal axis? So right now it looks like this. Here's our sinusoidal axis. What if, and here's January, and here's December. What if we turned it this way? So here's the sinusoidal axis, here's January, here's December. In other words, our low temperatures are in July, and the high temperatures are in January and December. Well, this is going to occur in the southern hemisphere, specifically somewhere that would be similar in latitude, only latitude in the southern hemisphere, as we are in the northern hemisphere. Someplace maybe like Australia, maybe somewhere in South America, those types of places would have that happen. Now we can look at a couple other graphs if you want to try these. Fargo, North Dakota, here's an equation for that. Notice that in Fargo, North Dakota, we have a different sinusoidal axis and a different phase displacement. Here's one where I use the negative starting point for the cycle. By the way, when you do the second example, this is one where you'd want to go to your graph and do menu and zoom data to change the window settings for the new data, or it won't all show up. Notice that we have a lower sinusoidal axis, so that means the average temperature is lower. But we have a larger amplitude, which means there's more variation in temperature. Actually, North Dakota is known for extremely hot and cold temperatures. What about if we were in Honolulu? Well, we would notice a higher sinusoidal axis because the average temperature is higher, but a lower amplitude because there would be less variation in the temperature.